All right, so first of all, let's start with the easy stuff. This guy here is an exponential model. In the middle, a quadratic model and a linear. I'm pretty certain we probably can do that part right now, okay? All right, let's do this exponential, okay? X-intercept, there is not one. Y-intercept is 4. And also remember, you can write the y-intercept as an ordered pair, and that ordered pair would be 0, 4. How do we know where the 0 goes and where the 4 goes? Well, y'all, if it's a y-intercept, then the y-coordinate has to have the 4 on it, okay? All right, here, x-intercepts. Y'all, we have 2. -1 and 3. How do we write them as ordered pairs? It would be -1, 0 and 3, 0. Notice x-intercepts means these are x values, so notice they're going in the first spot of the ordered pair, and then the other one's a 0. All right, with the linear, x-intercept is here, it's 6, and we can write it as 6, 0. Y-intercept is -4, and we write that as 0, -4. Folks, notice the difference in how the x-intercept and the y-intercept are written. Okay, also notice, x-intercepts for linear, how many do we have? 1. X-intercepts for quadratics, how many do we have? 2. How many do we have for the exponential? None. It doesn't cross the x-axis at all. So see those 3 differences in that. Okay? All right. I didn't do a y-intercept here. I'm sorry. Y-intercept here is -3. We would write that as 0, -3. Okay? How we doing so far? We good? Okay. Exponential model does not have a vertex, does not have a maximum and minimum. Y'all, you have to have a vertex in order to have a maximum and a minimum value. You've got to have a vertex, okay? This has no vertex, okay? Linear has no vertex. Therefore, there is no maximum or minimum value. Between the 3 of these functions, a quadratic is what has the vertex. So remember, the vertex is the point where the graph changes from increasing to decreasing or decreasing to increasing. It's where that change occurs. That ordered pair is the ordered pair 1, -4. The vertex is an ordered pair. In this case, this is a minimum, and I'm going to tell you what a student asked. A student asked is the reason why there's a minimum here because it's in a quadrant down below. Y'all, that's not why it's a minimum. The reason why it's a minimum is because it is the lowest place on the curve. It's the lowest place on the curve. So just letting you know, y'all, I could easily have a graph up here. Y'all, that is still a minimum. It's not about where it's placed, it's about the fact that this is the lowest point. Okay? Same thing with a maximum. Y'all, it doesn't matter what quadrant it's in. If it's this way, it's going to have a maximum. It doesn't matter where it's at. That would be a maximum because it's the highest point of that curve. Okay? So just letting you know, some people think it's got to do with the quadrant you're in. It has nothing to do with that. Okay, so the minimum value is always the y-coordinate because the y-coordinate tells us how low it is. So the minimum value is -4, and you might want to circle minimum. So y'all, again, take a look all the way across. The quadratic is the only one with the vertex and a maximum or a minimum. The linear and the exponential do not have vertexes. Good? Okay? Here, asymptotes. A quadratic does not have an asymptote. A linear does not have an asymptote. It's the exponential that has an asymptote. And let's remember what we talked about that an asymptote is. It is an imaginary horizontal line that the curve never touches. And you may look at that and go, well, Miss Batchick, that curve clearly touches the 3. Y'all, the way they draw graphs, it's just difficult to make it not touch the 3, but that graph truly never gets to the 3. That's like an imaginary fence line. Okay, so how do we write it? Y equals 3. Since it's a horizontal line, the way we write an equation for a horizontal line is with a y. Y equals 3. Notice, asymptotes, only your exponential models have those. It's an imaginary boundary line that the curve does not touch. It doesn't cross it. Okay? Questions on that? Okay, increasing and decreasing. This particular exponential function is increasing everywhere, so all the x values are represented. So this would be all reals is the way you would see that written, because it's every value, every x value from negative infinity to positive infinity. It is not decreasing at all, so there is no spot where it's decreasing. Okay? Okay, now let's go over here to linear. This particular one is increasing everywhere. So that would be increasing for all real numbers. And it is not decreasing at all for that particular one. Okay, now for the quadratic. The reason why I saved the quadratic is because notice, y'all, this is the one that has an area of increasing and an area of decreasing. Okay, so where does the change take place? Well, the change takes place right here, which is where x equals 1. This is where the change is taking place. Before that, remember, for increasing, decreasing, you're always in the roller coaster coming in from the left. So as soon as I hit this curve, it's going down. So this side is decreasing. And then after I pass my vertex, it's starting to go back uphill again, it's increasing. Okay, so y'all think about this. If this is where the x is 1, right here, then on this side is where x would be greater than 1. And on this side of the number line is where x is less than 1. So notice, decreasing is over the interval x is less than 1. The increasing part of the graph is where x is greater than 1. In behavior. For every one of the in behaviors, you can go ahead and write it like this to get started. X goes to positive infinity, comma. X goes to negative infinity, comma. Every one of them start off that way because this is not the part that changes. So you can fill that out across both of those. It's the y part that changes, not the x. So you're going to write x approaches positive infinity, x approaches negative infinity, and let's go ahead and do that on all of them. So on all of them, because the x part doesn't change. Okay. So basically when it says x approaches positive infinity, they're saying what's going on the right-hand side. when it says x approaches negative infinity, they're saying what's going on the left-hand side. Let's start with the easiest one. Let's start with this guy right here. Let's start with the quadratic. Tell me what's going on both sides. What's the y doing? The y is increasing. It's going up. Y's are going to positive infinity. So the quadratic's pretty easy. Both of these are y goes to positive infinity. Both of them. And keep in mind, for quadratics, they either have to, y's go up or y's both go down. They can't go like that. Okay. All right, let's go with this one. Okay, the right side of the graph, where are the y's going? Up or down? Up. Okay, so here's the right side of the graph. Y is approaching positive infinity. That means getting bigger. Okay, and then this is the left side. Where's y going? To negative infinity. That's correct. Y goes to negative infinity. Notice with your linear, y'all, one's going up and one's going down. Quadratic can't have that because of the shape. They either both have to be going up or both have to be going down. Linear is going to have one of each. Okay? All right, and then for end behavior with the exponential. The right side is pretty normal. Where is the y going? Up. Okay, but the left side is tricky. Y'all, the left side is not going all the way down to negative infinity. There's a fence stopping it. So, y'all, it's going to 3, but never touching 3. Okay? So, where are we at? Here. As x approaches positive infinity, y approaches positive infinity, because on the right-hand side it's rising. As x approaches negative infinity, that's here, it is approaching 3. Y is approaching 3. The curve is going down to 3, and it's never going to get there. It's never going to get there. It's going to get closer and closer, but it's never going to get there. Okay? All right? Okay. You may want to write a little cheat note here if you're struggling with this one. This is the hardest one. Y'all, this is the same thing as saying y greater than 0. And y'all, remember greater than 0 means greater than 0 means positive. So they're saying where are the y values positive? Well, that happens above the x-axis. Above the x-axis. So if you're like writing yourself little notes, maybe write above the x-axis and write below the x-axis. Write above the x-axis and write below the x-axis if that helps you with this notation. Okay? So they're asking you what are the values of x where the curve is above the x-axis, where y is greater than 0. Well, y'all, right here's the x-axis. The entire graph is above the x-axis. All the x values are above the x-axis, from negative infinity to positive infinity. So, y'all, that is actually all real numbers. It's all the numbers. All real numbers. The entire graph is above the x-axis. Below the x-axis, you can put a dash because there is no graph there. The graph does not exist below the function does not exist below the x-axis. Okay? Okay, let's take a look at this one. Okay, below the x-axis is this guy. He's below the x-axis. Well, what value does he start at? And what value does he end at? So how do we write that? He is in between -1 and 3. Oh, wait a minute. Sorry. I put that under the wrong one. Sorry. Sorry. This is below, this is less than, and I wrote it in the wrong way. It should go right there. Sorry about that. Okay.
What?
I'll say again, y'all, originally I wrote my answer there. That's the wrong place. I should have written it here. There's where it goes. Why? Because where the curve is between -1 and 3, right here, that's below. That's below. Okay, now, the part we've really not done much with, where is it above the x-axis? Well, y'all, there's two pieces above. Do y'all see the two pieces? Okay, one of the pieces is where x is greater than 3. The other piece is where x is less than -1. This piece is where x is greater than 3. This piece is where x is less than -1. This is where the function is positive. X is less than 3 or greater than 3, x is less than -1. There are two parts to that answer right there. Two parts. Two parts. Okay. All right. We haven't done this, but it's actually not hard. Okay, where is the function positive? Notice, y'all, right here's where the change takes place. Right there is where the curve begins to rise above the x-axis. Right here is where it's below. So I can even, to help you visually, I can even put highlighted color there and then highlighted color here, because see, right here is where the graph changes from being under the x-axis to above. So y'all, that value is 6. Over here is where x is greater than 6. That's this guy. Over here is where x is less than 6. That's this guy. So the graph is above the x-axis where x is greater than 6. So that's here. And y'all, one thing you don't want to do is memorize that if I see a greater than sign, then that's greater than. That is not, that's just coincidental. That is not the way it works. Okay, and notice where it's, the y values are negative, where it's under the x-axis, that's everything to the left of 6, which is where the x values are less than 6. Okay? Okay, something to take note of. The domain. The x values that are found on this curve, they go from -infinity to +infinity. The domain is all reals. The domain goes from, it's going to go as far as it can this way, as far as it can this way. The domain here is all real numbers. Goes as far as it can to the right, it goes as far as it can to the left. The domain is all real numbers. Y'all notice that the domain for all three of these functions is all real numbers. If you want to write all reals, or you could just write reals. Reals is a number system that includes the pretty numbers you like 5, 6, and 7. The decimals you don't like 5.3. Okay, it's all the numbers. All the x values are covered. Okay, now the range gets weird. Okay, first of all, for this one, the range is all real numbers. Why? Because it's going to go up forever, it's going to go down forever. All the y values would be included on this line. So the range here is still all real numbers. All real numbers. Okay, now the range here is not. Notice range is your y values. Y'all, there is no curve under -4. There's no curve at all under -4. So all of these values, all the y values on this curve are -4 and up. So how do I write -4 and up? I write y is greater than or equal to -4. Why am I using a y? Because range is what? The y values. The y values on this curve are all greater than or equal to -4. And y'all, if you're really watching similarities, look here. Do you see that's minimum? That is the lowest point on the graph. And notice I've written the range as y is greater than or equal to -4. Okay? Okay, here, check this out. Y'all, if you look down here, there is no graph. There is no curve here. That exponential model is not down here. It never comes down to the 3. It comes as close as it can get to the 3, but it never comes to the 3. It's everything above the 3. So how do I write that? I write y is greater than 3. Why am I not using an equal to bar here? Because with an asymptote, it will never touch the 3. It'll never touch the 3. Why am I using an equal to bar here? Because this curve literally touches the -4. Okay? And last but not least, constant means the same. There's only one of these that the slope is, that, by the way, average rate of change, or rate of change is slope. If you didn't know that or didn't remember that, write slope. There's only one of these functions that has a constant slope. Which one is it? Which function has the same slope everywhere? Linear. So if you go over to linear, you can answer yes, and the other two would be a no.